Time given is 2.5 seconds. What is the criteria given? What are we supposed to calculate? Velocity of the carriage. If you can find the acceleration, the job is done. Yes. How do I get the acceleration for this? I am pulling this. This will be F. This will be F. Right? This will be F. This will be F. This will be F dash. This will be F dash. Right? So now F minus 2F is 6 into capital A. F minus F dash is 4 into small a. F into R plus F dash into R is M into R square by 2 into alpha. Then A is equal to R into alpha. Capital A is 2R into alpha. क्या है इस क्वेश्चन? You get A. Once you get A, अरे भाई मैं समझा रहा हूँ ना, उसको गुस्सा कर रहे हो ऐसा कि जैसे उसने गलती कर भाई, it's okay, करा रहे हो. Capital A let's say equal to half A T square. 4R भी होगा भाई, कहाँ पे 4R चाहिए? 0.075. एक प्रॉब्लम अननेसेसरली करवाया आप लोगों ने.
सर वो ऊपर नहीं,
किसने करवाया? मैंने नहीं.
बट सर ऊपर लिखा ही नहीं तो 10 में कम
नहीं, जो किया है गलती उसकी.
सर ऐसा करो.
Strangely, nobody asked me 8th question. आप लोग सच्ची में किया है एक्सरसाइज? एट आंसर 100% सही है. आता है.
एक आपकी तरफ से.
अब सुनो, ये बुक किसका है? आपका है. इसने 8 मार्क नहीं किया है, मतलब किया नहीं बंदे, राइट? और पूछा भी नहीं, राइट? Hence I will not solve.
So 5 by 7.
12 सेंटीमीटर पर सेकेंड. क्या कर रहा हूँ यार? This is 12 centimeters per second. Inner radius 2 centimeters, outer radius 4 centimeters. Remember, this will not be the instantaneous axis of rotation, right? It will be, suppose I take from here, this is R1 and this is R2. R1 plus R2 will be, this is 2, this is 4, 6 centimeters. Right? 12 by R1 is equal to 12 by R2. That means R1 is equal to R2 equal to 3 centimeters. So this is the position of instantaneous axis. You want me to calculate omega? Now V1 by R1 will be omega. Which question am I discussing? Instantaneous center हो गया. Velocity of the slider. How do I get velocity of the slider? I want this VC, right? Velocity of this point P with respect to center of mass plus velocity of center of mass with respect to ground is velocity of point P with respect to ground. इसका कैलकुलेट किया. O. Velocity of point P with respect to O plus velocity of O with respect to ground is velocity of P with respect to ground. Now you know this is R omega. R means how much? This total distance is 4. Omega you already calculated. Plus VCM, velocity of O, should be velocity of the point which is 12. होगा आपसे सेकंड वाला खत्म करें.
बट इसमें वेलोसिटी ऑफ स्लाइडर का पुनिया मतलब ओवर डिस्टेंस ज्यादा से स्लाइडर का रहेगा. तो अगर ये ओवर स्लाइडर तो फिर जो एजेंट एक्सेस रोटेशन है वो भी उसी कारण उससे वेलोसिटी को मूव करता है.
If thin rod has BCM this way and omega this way, will this point have the same velocity as that of center of mass? R omega plus BC.
but वो साइड का भी ऊपर है ना, तो साइड का ऊपर करेगा उसका ऑब्जेक्ट
There is a third bit also for this question. Length of the cord wrapped on each pulley per second. Length is the distance.
So for this one, we know omega about the instantaneous action of rotation. So can't we just put that on the instantaneous velocity?
Try first bit में instantaneous accuracy calculate.
I'm saying second bit, can't we just do v about c at home?
Right? Perfectly right. This is addressed. Velocity of O with respect to C is 0.1 into omega.
Yeah, clear.
Now, what is the third bit? Length of the cord wrapped or unwrapped on each pulley per second. The length of the cord is depending on the velocity of this point. This is the cord, right? Huh? Right, so 12 centimeters per second.
So this is moving down.
ऐसे relative से depend करेगा ना? हाँ. अच्छा, relative velocity क्या है?
Right. How much did you calculate this?
That is 12. C1 is 4. So O down.
O का कितना आया? Velocity of O 4 centimeters per second. So now velocity of this with respect to O plus velocity of O with respect to ground is velocity of this with respect to that gives you the length per second. कितना wrap हो रहा है? Last but one bench, the last two benches, you are continuously disturbing. You need to listen to the doubts and participate in the class. I don't have high energy level today. Controlling you will be very different. You will have to cooperate. Right? Now,
So velocity that point vary है, but किताब में respect to ground ही करेगा.
right? That is with related this with respect to O plus velocity of O with respect to ground. I'll get the velocity of this with respect to ground. We need relative, fair enough, right? Listen, it's my mistake. You are finding this with respect to this particular pulley, so that I know how much is wrapping up. Never did the third bit. Did you ever anyone simplify the third bit?
No.
8 and 16 सही है, right? Subtract. एक में subtract हो रहा है, एक में add हो रहा है. Never concentrate. Can I rub the board?
Yes. Last week है. 13 तो 30%. Last week है.
नहीं, हर साल 8 is a standard doubt when I discuss. I don't know. Now, what did you say? 14. Two particles 7m and 3m are fastened to two ends. Fastened to the two ends, A and B respectively of the weightless rigid rod 15 feet long, which is freely hinged at 0.25 feet from A. If the rod is just disturbed to the position of unstable equilibrium, listen, define unstable equilibrium. Sir, दोनों benches को politely request किया है. एक और बार रिक्वेस्ट कर रहा हूँ, राइट? नेक्स्ट आई विल नॉट, फेयर ना, राइट? इससे ज्यादा मौका मैं नहीं देता। नाउ अनस्टेबल इक्विलिब्रियम में पोटेंशियल एनर्जी शुड बी मैक्सिमम. Now 7m is above, 3m is below, and you are telling me it is hinged at a point to 5 feet from A. This is A and B. It is hinged at a distance of 5 feet. This should be 10 feet. If the rod is slightly distant from the position of stable equilibrium, sorry, unstable, then I am committing a mistake even now. I am committing a mistake even now. Center of mass should be above. Here center of mass is below. नहीं, center of mass above ही आएगा. ढंग से देख लो कितना होगा center of mass distance. 4 point कुछ आएगा इधर. 3. This is COM. 7 into, I take this as the origin, 7 into 0 plus 3 into 15 divided by 7 plus 3, 45 by 10. What I remember was correct. This is 4.5 from here. That means center of mass is above. Now you slightly disturb it. What will happen? This 3m should come here and 7m should come here, and this should be below this. It will be 0.5. 0.5 feet. Feet है वो गंदा है. This is 0.5 feet. Now it turns. This center of mass should come down by 0.5. मतलब center of mass came down by how much high? Actually, now you should find the velocity with which A will pass through its position of stable equilibrium. Loss in potential energy is equal to gain in, and take I about the hinge. Interpretation in the problem, no doubt. The language is tricky. 14th is a genuine doubt. वैसा ऐसा डाउट ही पूछता है. आप क्वेश्चन देखो, स्टेबल अनस्टेबल बोला है, दो ही ऑप्शंस है, राइट? 14 के बाद I give you one more choice.
16 का B और C.
16 is a genuine doubt. सुन लो. A 500 grams block. This concept we will use again in gravitation. भूलना. Gravitation में when a particle is fired from the surface of Earth, when will it go to the maximum height? We will use this concept. No. मुझे बोलने दो. When will it go to the maximum height? Maximum height is when R is perpendicular to A. I am not throwing this way, right? It will go in an elliptical path, right? There R is perpendicular to V is the maximum height. What is the logic? ध्यान से सुनो. By chance, if this has a velocity component in this direction, then that will not be the maximum height. It will further go up. If it has a velocity in this direction, it will come closer. So the maximum height will be when this will come like this. The maximum displacement, any elliptical orbit you take, even for sun. Share the joke with them. We'll continue. If you have a problem, we'll wait. Continue. Proceed. जोक तो बता दो पूरा, आधा जोक बता के उसका चेहरा देखो कैसा है. बोलो. This is R1, this is R2. Condition of maximum distance and minimum distance. This is called the closest distance of approach, farthest distance of approach. They have two beautiful names, perihelion and aphelion. Right? In maths में they call those 2 points perigee and apogee. In gravitation they call it perihelion and aphelion. Right? What is the condition to recognize that? velocity is perpendicular to r. Any other place you take, velocity will not be perpendicular to r. It will have a point either away from the sun or towards the sun. It's either moving closer to the sun or moving away from the sun. See, this is r, this is v. Velocity is not perpendicular to r. At the farthest and the closest distance of approach alone, velocity will be perpendicular to r. Now you obviously know why I explained that. Yet I will solve this. This is an important question. So look. 16. 500 grams block P rests on a frictionless smooth table at a distance of 400 meters from the fixed pin. 0.4 meters. The block is attached to the pin of the block. Which question am I reading? Okay. Elastic coordinate K 100 Newton per meter and of undeformed length 900 meters. Millimeters again. If the block is set into motion perpendicular, speed in the beginning for which the distance from O to the point P will reach the maximum value of 1.2 meters. If it is 1.2, maximum value means B should be perpendicular to R. Right? B should be perpendicular to R. Now listen to this. Initially you gave this a velocity of u. This is hinge. So initial angular momentum is mu into 0.4. Final angular momentum mv into 1.2. Now mvr, don't you think you'll have to put sin theta here? Sin 90. I have to put sin 90 is 1. Right? This is my first equation. Second, conservation of energy. Half mu square will be half mv square plus half kx square. How do I get x? 1.2 minus 0.9.
0.3.
Oh, smart. Right? Rubber band. Initially it is kept this way. Compressed है.
ये समझा कि स्प्रिंग है कि स्प्रिंग है
String है, but it has elastic nature.
स्प्रिंग की तरह
Again I lost track. Hey wait, first इसमें से दोनों options आ गए. Now radius of curvature of the path of the block when OP is 1.2 meters. Radius of curvature kx provides the required centripetal force. kx provides the required, b पता है आपको, x पता है, kx provides the required centripetal force. बाहर आएगा? He's right. mv square by r. उसका minimum पूछा है. Minimum velocity for it to have that elongation of 1.2. For it to come to 1 point. That means this velocity component will be 0. We finished exercise 1 discussion.
Yeah.
Online.
And did we do that J mains exercise? Assignment 1 and 2?
No. Assignment was
Assignment 1 and 2 में कोई doubts है? एक दो होंगे मैं. Can I have the board?
Yes, sir.
You have a question.
Sphere A, mass M, radius R, rolls without slipping with a velocity v1, horizontal plane. It hits squarely an identical sphere B, which is at rest, denoted by mu k, the coefficient of kinetic friction between the sphere and the plank. Like plank counts as sphere, this is plank, right? Sphere is, when both spheres are the same mu k, is it? Sphere and the plane. Neglect the friction between the spheres and between the spheres, receiving perfectly elastic collision. Linear and angular velocity of each sphere immediately after the impact. Velocity of each sphere after it started rolling uniformly. Discuss the special cases when mu is equal to 0. Oh bhai, doubt किसमें A B C D में A B C. Hey, listen, you are just conserving linear momentum. It is the both are identical masses. Identical दिया है, perfectly elastic collision दिया है, तो interchange कर लो नया velocity. The friction will not come into the picture. It will be non-impulsive at this particular point because it is horizontal. Unless you have a normal pole this way, this friction will be non-impulsive. Right? So directly you can conserve linear momentum. Just after collision, this comes to rest. This starts moving with a velocity v1. After some time, it will roll. Why will it roll? Friction is acting backwards. So after some time, this will be v1 dash and omega dash. Conserve angular momentum about this particular point. Pहले sphere comes to rest. Why will it have omega? कहाँ से आ रहा है? ओमेगा है ही नहीं इनिशियल में. Sorry, okay, my mistake. It has initially omega. This will also roll because this will have r omega this way and friction this way. So after some time, what will happen to this? This friction will increase v and it will decrease omega. I'll call it omega final, v final. It will also roll. सही में आंसर सही है.
सही है
आंसर आएगा, डोंट वरी.
सही है आंसर करेक्ट है.
ये आज तक किसी ने बताया नहीं है, करेक्ट होगा ही होगा. मैंने सॉल्व कभी नहीं किया.
ये ओमेगा पे सर कैसे होगा? रिवर्स में नेचुरल होगा. आपका वेलोसिटी भी ओमेगा वैसे होगा.
So okay, don't worry. Hey, this is an easy one. We wasted our resources unnecessarily. Can I rub the board? What did we discuss right now? 20. Now 21. Stationary free rod AB of okay, a stationary free rod of AB of mass m on a smooth horizontal plane is struck at A by a particle of same mass moving in the same plane with velocity v not perpendicular to the rod. Coefficient of restitution is small a. XY coordinates of the end B as a function of time, taking the origin to be fixed at the initial position of the center of the rod. Find the initial position of the center of the rod as origin. The positive y-axis along the rod and take A towards x-axis. Listen, not very difficult. This is quite easy. They made it look complicated. That's all. I wish I concentrate. A B. This is small m on a smooth horizontal surface is struck at end A by a particle of the same mass. Particle of the same mass moving with a velocity v not perpendicular. The coefficient of restitution is small a. Right? Now, This will be moving with the velocity v. This is v naught. And I call this VCM. This as omega. This will be L by 2 omega plus VCM. Right? Find the x and y coordinates of the end B as a function of time, taking the origin to be fixed at the initial position at the center of the rod. Fixed at the initial position of the center of the rod. Right? Now, take the initial position of center of the rod as origin, positive y-axis along the rod and towards A, and x-axis along the initial velocity of the particle. That's what we told them. Okay, Jai. What did he ask? For B, he asked coordinates. Y coordinate of the end A. क्या बोल रहे हो यार? VCM and omega बताने से आंसर आ जाएगा कि नहीं? MV naught is equal to FV plus M into VCM. Conservation of linear momentum. I drew the traditional one. I conserve angular momentum about this. It will be M V naught into L by 2 is equal to MV into L by 2 plus ICM into omega. Third small e is half L by 2 omega plus VCM minus V upon V naught minus 0. Three equations and three variables. You are asking me the coordinates of B after time B from this origin. Once I know omega, I know VCM. I know distance moved by B. Yes or no? Should not be difficult. If it rotated by an angle theta, y coordinate will be L by 2. If it rotated by an angle of theta, I take this to be theta. Y coordinate is L by 2 cos theta. X coordinate is L by 2 sin theta minus VCM. X coordinate is L by 2 sin. VCM is only along X. So X coordinate is, I will take VCM minus. Right? Recording कर रहा है. You don't need to say no, I'm okay.
हाँ.
I don't feel deterred by that. Comfort always.
Smile please.